All right, so we're on page 159. This is still in section 8, but again, I'm kind of like going a little bit away from algebranation, so I don't have a topic to give you. So this is still in section 8, just not a particular topic. I've kind of just pulling stuff from different places. And we are going to title this Rational Exponents. All right, so last class we talked about radical equations. And remember, a radical equation is when you don't just have a radical in your equation, but your radical, there's a variable under the radical sign. That's called the radicand. The radicand has a variable in it. That's what makes a radical equation. Also, what makes a radical equation is if you have a rational exponent. So you may not see a radical at all, but if you have an exponent that's rational, that means a fraction in simplest form, then we can turn that into a radical equation. And so that's also considered a radical equation, all right? So you can write a radical expression in an equivalent form using a fractional, and in parentheses I'm going to put rational exponent instead of a radical sign. So for example, if I have the square root of 36, I know the square root of 36 is 6. I'm not taking the square root right now. I want to rewrite it instead of writing it as a radical. I want to rewrite it so that there's no radical, but it has an exponent that's a fraction. Okay, you can do that. They mean the same thing. So first of all, what is the index here? Y'all remember what index means? It's the little number that's in the elbow of the radical. There's a 2 there. It's implied. We don't really have one, but there's a 2. And I'm going to write it this time just so that you can see where I'm getting my numbers. And what is 36's exponent? What's its exponent? 1. There's nothing written there. It's implied as well, right? So if I want to convert this to a number that has a rational exponent, what you do is you keep the base of 36. The exponent of the base is the numerator of the fraction. The index is the denominator of the fraction. So if you see 36 raised to the 1/2 power, that's the same thing as what's the square root of 36. All right, it's just written in a different form. It's like a fraction converted to a decimal. They mean the same thing. They're just written in a different form. All right, so you need to be able to go from radical to rational exponent or from rational exponent to radical. This is how I remember it, because if you just ask me to write the cubed root of 49 to the 3rd power, I would have to go back and think about a square root problem to remember what goes where. Because I know that when you have something that's, if you're taking a square root, it's always, the exponent is the denominator. I know it's always raised to the 1/2. So that's why I remember what goes where. Okay, so think about that one, and that helps me to know. So if I had, let's say, the cubed root of 64, and I want to rewrite it as a base with a rational exponent, what would it be? 64 raised to the 1/3. So we've got radical form, and this we call exponential form. Because sometimes if you were given like, okay, what's 64 to the 1/3 power? To me, it's easier to think about it as the cubed root of 64. So you could just switch it over, convert it to the radical form to be able to simplify it. You can simplify it like this, but if that confuses you, like, oh yeah, I can convert that to a radical and that'll be easier for me to conceptualize. Maybe it's not. Maybe that's easy for you. So what if I had the 4th root of 16 cubed? 16 raised to the 3/4 power, exactly. Now, if I were actually simplifying this problem, you could either do 16 cubed first and then take the 4th root of that, or you could take the 4th root of 16 and then cube it. It doesn't matter which order you go as long as you do both things, okay? How about the square root of x cubed? X raised to the what? 3/2. Set exponent over the index. What if you had the 5th root of m in quantity squared? So mn would need to be in parentheses because that means both m and n have an exponent of 2. And both m and n are raised to the 2/5 power. Now let me show you the difference. If m and n were not in parentheses, that means only n has an exponent of 2, not m. What's m's exponent? 1. So you'd have to write it separately, okay? M would be raised to the 1/5 times n would be raised to the 2/5, okay? Parentheses make a difference. Does that make sense? Yes? No? Maybe? Oh, thank you. Good. I'm glad. Okay, so let's convert between exponential and radical form. We'll just do several examples going back and forth, okay? We need to know how to do this because we're going to have some equations where we have rational exponents, and we need to know how to convert it to radicals so we can solve it, because we know how to solve radical equations already, right? So converting between exponential and radical form. Man, a lot of fluffy points being lost on first day of the quarter. No, you weren't. But you knew who I was talking about, didn't you? Okay, first example. Let's write x to the 3/7 power in radical form. How did you say it? So we would say, so your index is 7, right? So we would say the 7th root of x cubed. Can we take the 7th root of x cubed? Like, could we simplify that? No, because we need 7 of the same factors, right? And x cubed would only be 3, x times x times x. So we could not simplify that if it asked us to. We didn't have to, but let's convert. We're not going to write the directions every time, just depends on how it's given to us. If we have x raised to the 1/6 power, what would that be in radical form? Right. The 6th root of x. Do I need to put to a power of 1? No. It's not wrong if you do, but if it's not there, it's implied to be a 1. How about x raised to the 2/5 power? What's my index? 5. So the 5th root of x squared. Could we simplify that if we were asked to? No. Okay, here we go. How about x raised to the 1 5/10? Okay, we know what to do if we have a rational exponent, but this is a decimal. Okay? Anybody have any idea what we would do?
Change it to improper.
Yes, we would change it to a fraction before we could write it as a radical, okay? So, and I'm going to do this in steps. I'm not just going to go right to it. We know that 1.5, the way you say that is 1 5/10. The proper way to say it is not 1.5. So that helps me write the fraction too, okay? Which we know 5/10 reduces to 1 1/2. All right? Well, that's a mixed number. We don't know what to do. We can't write that in radical form, so we need to change it to improper. What's 1 1/2 as an improper fraction? 3/2, 3/2. Remember, because you take the denominator, multiply by the whole number. 2 times 1 is 2. Add the numerator, so you have 3, and then you keep the denominator. So it's x raised to the 3/2. Now, can we write it in radical form? Yeah, what would it be? What's my index? 2. So the square root of x cubed. And if it asked us to, could we simplify that? Yeah. All right, I have 2 more of these. Let's do the 4th root of, open parentheses, 5ab quantity raised to the 3rd power. Do I need parentheses around the 5ab? Yeah. Raised to the 3/4. So 5 is raised to the 3/4 power, a is raised to the 3/4 power, and b is raised to the 3/4 power. If we didn't have parentheses, only b would be raised to the 3/4 power, and 5 would be raised to the 1st, and a would be raised to the 1st. So parentheses make a difference. All right, how about this? The cubed root of 5x squared, no parentheses. 5 raised to the 1/3, x to the 2/3. And those are being multiplied together. We don't have to write multiplication symbol, right? Is everybody cool with that before we start these equations? Yes. Easy. Everybody cool? All right, page 160. So I got a new title here, Solving Other Radical Equations. We know how to solve radical equations. That's what we did last class. But those equations were clearly radical equations because you could see the radical and you could see that there was an exponent in the radicand, okay? These aren't going to, you're not going to see the radical to start with because there's not one, but you have a rational exponent, which means you could convert it to a radical, which makes it still a radical equation. All right, so in my first example, we have to solve 3 times the quantity of x plus 1, quantity raised to the 2/3 power equals 12. So first thing we're going to do, just like when we did radical equations, because technically this means the cubed root of x plus 1 quantity squared, okay? But don't write it as a radical because you're going to confuse yourself. It's easier if it's written like this, okay? But just like we isolated radicals, we have to isolate the parentheses. All right? So yeah, we'll divide by 3. And now we have x plus 1, quantity raised to the 2/3 power equals 4. So again, we could turn it into a radical, but the easiest thing to do is, you know what happens when you multiply a number by its reciprocal?
It cancels.
And turns into what? What number? 1. Somebody said it. So if I have 2/3 and I multiply by its reciprocal, what's the reciprocal of 2/3? 3/2. So if I multiply, remember when you multiply fractions, numerator times numerator, denominator times denominator, and what does that reduce to? 1. Well, if 1 is my exponent, do I need to write it? No. That would make this 2/3 go away if I multiply by the reciprocal, okay? But what I do to one side, I have to do to the other, right? That's what equations are all about. So I'm going to rewrite this in another step so that when you go back and look at your notes, you can see how the steps progress. So I'm going to raise both sides to the reciprocal of the exponent. Not multiply both sides, raise both sides. Because the whole goal is to try to get x by itself, right? We want to solve for x. Well, x is inside parentheses that has an exponent other than 1. So we have to figure out how to get rid of that exponent before we can subtract the 1 away from x. So what's x plus 1, quantity raised to the 2/3 power, quantity raised to the 3/2 power is going to be what? Just x plus 1. Quantity raised to the first would just be x plus 1. And then 4 to the 3/2 power, let's convert that to a radical. So what would the index be? Square root of 4 cubed. And remember, when we square one of our side, or take the square root, we take the positive and negative square root. Okay, so we have x plus 1 equals positive or negative. Let's simplify this. I'm going to show you over here. I'm going to do the square root of 4 cubed. You can do it one of two ways. You can take the square root of 4 first. What's the square root of 4? 2. And we haven't cubed anything yet. And then cube 2 to get 8. We can do it that way. Or you can cube 4 first. What's 4 cubed? 64. So we haven't taken the square root of anything. We just cubed it. And then what's the square root of 64? 8. Either way, you're going to get the same answer. Just don't forget to do both operations, okay? So we have positive, negative, 8. If you forget to do the positive, negative, you're not going to get two answers. And in that case, you're going to only get half credit, okay? So at this point, I would make two separate equations. I would set x plus 1 equal to positive 8, and I would set x plus 1 equal to negative 8. And then you can just solve them separately. And let's just check our answer. Let's substitute 7. You can substitute it into the original or after your parentheses are isolated. 7 plus 1 is 8. 8 raised to the 2/3 power. Let me see. Might need to write this down. Again, you can plug it into the original. Or once the parentheses are isolated, I just feel like that's easier, less steps. So we have 7 plus 1 raised to the 2/3 equals 4. So that's 8 raised to the 2/3 equals 4. And I would just change that into a radical. So that would be the cubed root of 8 squared. 8 squared, 64. What's the cubed root of 64? So 7 is actually a solution. It does not give me an extraneous solution. And let me check negative 9. So I have negative 9 plus 1 quantity raised to the 2/3 power equals 4. So that's negative 8 quantity raised to the 2/3 power equals 4. So that's going to be the cubed root of negative 8 quantity squared. And what is negative 8 quantity squared? Well, no, we're squaring it. 64, and it's positive, right? And the cubed root of 64 is 4. Does 4 equal 4? Yes, it does. So negative 9 is a solution. Any have questions on that? Am I still writing? right, page 161. I have 3 more examples for you. We're going to solve 3 times the 5th root of x plus 1 quantity cubed. We have a plus 1 that's not under the radical, and we're setting it equal to 25. Okay, so this time we do have a radical. All right, we learned how to solve radical equations last class. What do you think we do first on this one? We can divide by 3. Yeah, subtracting 1 will be easier. So we have 3 times the 5th root of x plus 1 quantity cubed equals 24. Now what? We will divide by 3. Three divided by 3 is 1. So we have left the 5th root of x plus 1 quantity cubed equals 8. How many x plus 1 factors do we have? 3. We need 5. So are we going to be able to take 5 factors of x plus 1? No. Any idea what we could do? We could rewrite it with a rational exponent. Yes, exactly. We could rewrite it with a rational exponent. So we have x plus 1 quantity raised to the 3/5 power equals 8. Can we go ahead and subtract 1 from both sides? No, it's inside parentheses that has an exponent. So we need to get rid of that exponent. What would we do? We're not multiply. Well, we'll raise both sides to the reciprocal, right? And of course, I'm going to show my steps. So we'll raise both sides to the 5/3 power. Because 3/5, a power raised to a power, the rule says when you have a power that has a power, that's power to a power rule. The rule says you multiply the exponents. So that turns into 15/15, which reduces to 1. So x plus 1 raised to the first power is just x plus 1. Boom, we got rid of the fractional exponent. But on the other side, it's not quite so easy. 8 raised to the 5/3, we still have 5/3, right? It does not go away. So do we know what 8 to the 5/3 is, or could we? Exactly, it's the cubed root of 8 to the 5th. Now listen, when your index is odd, you don't do plus or minus. When it's even, we do plus or minus because the square root of 4 is what? 2, because 2 times 2 is 4. But isn't it also negative 2? Because negative 2 times negative 2 is also positive 4, right? But think about the cubed root of 8. Can the cubed root of 8 be negative 2? No, because negative 2 times negative 2 times negative 2 is negative 8. So if your index is odd, you don't do positive and negative. You do positive and negative when your index is even. Square root, 4th root, 6th root, 8th root, etc. Know what I'm saying? Okay, so this will only give us one answer. So if x plus 1 equals, I'm going to do this over here, cubed root of 8 to the 5th. Now on this one, I know 8's a perfect cube, so to me it's just easier to take the cubed root first. You could do 8 to the 5th first, or what's the cubed root of 8? 2. And then raise 2 to the 5th power. Our radical's gone because we took the cubed root. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So this time we only have one equation to solve, and x is 31. Let me check it real quick. And you can check it into the original. I prefer to check it into the equation once it's been, the radical's been isolated, because it's equivalent to the original. We kept it in balance. What we did on one side, we did to the other. So that would be the 5th root of 31 plus 1 cubed. So that's the 5th root of 32 cubed. What do y'all want to do first, 32 cubed or 5th root of 32? Y'all remember how to do 5th root on your calculator? What do you put in first? You put in the, what? You put in the index. So 5th root, and then hit what button? Math. Remember, square root only takes a square root. We have to go hit that math button, and option 5 means whatever index that we want, we already put in a 5. So option 5. It looks weird, but that means the 5th root of 32 is 2. So I took the 5th root first, so I have 2, but I haven't cubed it yet. And what's 2 cubed? 8 equals 8. Or I could have done 32 cubed first. 32 raised to the 3rd power is 32,768. And then taking the 5th root of that, so I do math, option 5, 32,768, and I get the same thing. All right. That checked out. Our answer is 31. Everybody cool with that? I have 2 more examples. The work that I'm going to give you, y'all should be able to finish easily in class, because I know it's prom this weekend, even though you're probably not going to do homework till Tuesday during 2nd period. But you should be able to finish in class. Anybody still copying that? Have a question on that, etc.? I
said Alicia.
Been doing this for a while. I always did my homework during school, like whenever I had a class that ended early. I'll get my homework done so I don't have to take anything home.
What a nerd.
Guess what? I got good grades.
So do I. I don't do homework.
Huh.
Yeah.
That's hard. It's hard to get a good grade in my class when you don't do homework.
Yeah, Brandon.
Okay, so in this problem, you don't see a radical, but is it considered a radical equation? Yes, because we could convert this to a radical and there'd be a variable in the radicand. So it is a radical equation. So we do it the same way, but even though we might not ever convert it to a radical, okay? What do you think we do first? You know it. 2 divided by 2 is 1. So in that first term, we're just left with x plus 3, quantity raised to the 2/3 power, equals 4. Do we want to convert that to a radical? No. Because we're going to take the cubed root of x plus 3 quantity squared, and we won't be able to simplify that because we don't have enough factors. So what we're going to do to get rid of the radical is we're going to raise both sides to the what? The reciprocal of 2/3, which is 3/2, right? Power to a power, 2/3 raised to the 3/2 means you multiply those powers together and you get what? 1. 2/3 times 3/2 is 6/6, which reduces to 1. And when you have an exponent of 1, you don't need to write that. You don't even have parentheses anymore. 4 to the 3 halves. Let's convert it to a radical. What would the index be? 2. So it would be the square root of 4 cubed. Will we need a plus and minus on this one or no? Yes, because your index is even. So you will have two answers. If it's odd, you don't need plus or minus. If it's even, you do. Coolio? So let me do this on the side. You can do 4 cubed first, or you can do square root of 4 first. What do you want to do? Okay, what is 4 cubed?
64.
And what's the square root of 64? 8. If we did the square root of 4 first, what's the square root of 4? 2. What's 2 cubed? 8. So we get the same thing, right? It does not matter which way you do it. So we have x plus 3 equals positive or negative 8. So is my answer positive or negative 5? No, you do not subtract 3 at this point. You make two separate equations. One of them set equal to positive 8. The other one set equal to negative 8. And then solve them separately. You can get extraneous solutions with these. Radical equations, you can get extraneous solutions. Make sure you check yourself before you wreck yourself, okay? So you can substitute your solutions into the original. I prefer to wait until I get my parentheses isolated, and that's where I check mine. I know I sound like a broken record, however, I want you to remember. So I'm going to substitute into x plus 3, quantity raised to the 2/3 equals 4. So substitute in a 5. 5 plus 3 is 8. Raised to the 2/3. So that's the cubed root of 8 squared. What's 8 squared? What's the cubed root of 64? 4. So we know 5's a solution. Let's see if negative 11 is a solution. Negative 11 plus 3. Negative 8. Just because we see that it's negative, don't automatically assume, because this is a cubed root. And can you take the cubed root of a negative? Yeah. So the cubed root of negative 8 quantity squared. What's negative 8 quantity squared? And that's positive, right? And cubed root of 64 is 4 equals 4. True statement. So negative 11 is also a solution. One more.
So last page. My last page.
Is there a last page of your notebook? Uh-oh. Better get a new spiral this weekend. I still have 38 pages. Well, fronts and backs. Oh. So I want to do this last example because there's part of it that we haven't seen before, and it's a place where students they get messed up on, causes them errors and issues. So I want to make sure to cover this last one. Does anybody have a question? Am I still writing? Are we good? All right, page 163. We have 4x raised to the 3/2 minus 5 equals 103. Is this considered a radical equation? Yes, it is. So we have to isolate where there would be a radical. We would have to isolate that. What should I do first? Add 5. So 4x raised to the 3/2 equals 108. Have I isolated the radical or the rational exponent?
Yes.
What's 4's exponent? 1.
So would you divide both of the 4?
Yeah. So that's the tricky part. Because a lot of students think, okay, well, we put this whole thing under the radical. Well, 4 doesn't have a rational exponent. There's no parentheses there. If there were, we would be good. But 4's exponent's a 1, so it's not isolated until we move that 4. Does that make sense? Okay. So we have x raised to the 3/2 equals 27. Now, do we want to turn that x to the 3/2 into a radical? No. What do we want to do? Yeah, we'll raise it to the reciprocal. Raise both sides to the reciprocal. So reciprocal is 2/3. So x raised to the 3/2 quantity raised to the 2/3 is just x. 27 raised to the 2/3 will turn that into a radical, which is what? Cubed root of 27 squared. That has an odd index, so would we do positive and negative? No. So we can do 27 squared first, or we can do the cubed root of 27. I would probably prefer to do the cubed root of 27, which is what? 3. And 3 squared gives you 9. We could have done it the other way. We could have squared 27 first. So 27 raised to the second power is 729. And then take the cubed root. So math option 4, 729, and we still get 9. Either way, same thing. Cool beans? Of course, I'm going to check it. And I'm going to check it at x to the 3/2 equals 27. So I'm going to substitute my solution in for x. 9 to the 3/2 equals 27. And when I'm checking it here, when I take the square root, I don't need to do positive and negative. So square root of 9 cubed. And I would probably take the square root of 9 first, which is 3. And 3 cubed is 27. So I know we haven't had any extraneous solutions, but you will find some, so you want to make sure you always check it. Check it before you wreck it. Anybody have any questions? All right. You will need a piece of paper for your assignment.